So, complex fractions. A fraction within a fraction with a bunch of fractions. Okay? If you write it like this, it just looks like, I don't know what to do. Okay? So there is one little trick that you can do that helps it appear to be better. Alright? It's still the complex fraction, people. Alright? But it'll look a little bit better. If you take the middle line, the one that separates the top fraction from the bottom fraction, and you make it a little bit bigger, then look what happens to it. Just visually, you just go, oh, okay, I just got a fraction on the top and fractions on the bottom. Okay? What does this middle line mean to do? Divide. How do you divide fractions? Yeah. Division by fractions is easy as pie. You flip the second, which is this one, so you're going to flip him up here, and you're going to multiply. Okay? Because division by fractions is multiplication of the reciprocal. Here's the rule, though. Very first thing, y'all, you cannot flip it and multiply until you've got one fraction on the top and one fraction on the bottom. Okay? So our very first goal is going to be to make one fraction on top and bottom. Okay? Now, once you've made that one fraction, then you should just flip. Oh, got a little dyslexia today. Flip the second and multiply. Okay? And that's going to be the bottom one. However you want to write it. You can flip the bottom one, whatever you want to do. Okay? But y'all, that's it. That's all we have to do. Okay? So, do I have one fraction on the top? Oh, check. I got that one. Okay? Do I have one fraction on the bottom? Alright. So the first thing I need to do is I need to make one fraction on the bottom. On the top, heck, I'm just writing that thing down. Okay? On the bottom, do I know how to add fractions? That'll be what we learned yesterday, right? So if you don't know yesterday's lesson, you're going to have a problem with today's lessons because that's what we're doing. So, in order to add and subtract fractions, what do you have to have? Okay, a common denominator. Remember the two things that I told you about a common denominator. A common denominator, it's every factor has to be represented, and you have to have the most that any one has. Now, like this is 1 and this is 1. So you had to have the most that any one of those had. All right. So what is my common denominator between x plus 4 and x?
X plus 4.
Okay. I like the x plus 4. Is that it? No. Because you represented this factor, but what? You've not represented that one. So I'm going to put that one down there too. Okay? Remember what we said. Every factor gets represented. Okay? Now, I'm going to specifically tell you how to do some things because, guys, I know 4 or 5 of you, I know the mistakes that you're going to make. Okay? I've had 2 classes. I've already seen it about 5 or 6 times. I know what you're going to do. Okay? So when I say to do something in a certain order, I'm trying to keep you from making that mistake. Okay? So, let's collect this bottom part. I'm doing this. I'm making one fraction out of the top and the bottom. Got one? Making one. All right. What do I do to this denominator to make it look like this? All right. So you can put the x down at the bottom if you want to. I don't like to, but evidently a whole bunch of y'all do. So I'll do it for you. So I'm going to multiply the top by x. Everybody agree? Now do it. Don't go working on the second part. You haven't even done the first part. What is 1 times x? X. Very good. Now, let's do the second part. What do you multiply this denominator by to make it look like this? Okay, so I multiply the bottom by x plus 4 and the top by x plus 4. Now do it. Now look. What am I writing? What visual cues am I giving to myself so that I don't forget to multiply the 2 times the 4? Because listen to me, the most common mistake is going to be for someone to write down 2x plus 4. Okay? Last period, 4 people brought their problem up to me and they all had done the same thing. Okay? So I know that's a careless error. What visual cue am I giving myself? Am I doing for me so I don't do that? Yeah, I'm drawing these little rainbow things. I'm saying, hey, man, you better multiply these, and you better multiply these. What's 2 times x? Now, is that multiplied? Is that x times 2x? No. There's a people, that's a big plus sign right there. He says, take this one and then add this stuff right here. So what I've seen is that kids, first of all, they didn't do it right when they put it down. And then when they went back, they just said, oh, that's x times 2 times x plus 4. Like, whoa, where'd you get that math? Okay? So do it then, and then don't make this into a times sign. It's not. It's a plus sign. So plus 2x plus what? 8. Perfect. Now, do I have any like terms here? What are they? 2x and x. What is 2x and x? 3x. So look, I could write the whole thing over again, right? But y'all, that's just a waste of my time, and time is valuable. So I'm going to cross it out. I could erase it, but if I erased it and someone looks back at my paper to get some help, they're going to come and ask me, where'd you get that 3x? See what I'm saying? But now, they can look and say, oh, that's where she got the 3x. See, I don't have to say anything to them. I'm going to say, here's my paper. You can see if you can figure it out. If you can't, ask me and I'll help you. All right? Okay. So now, do I have one fraction on the top and one fraction on the bottom? So now what can I do? Flip it and multiply. So times, how do you divide fractions? Multiply by the second one's reciprocal. So that's what I'm doing, guys. That's how you divide. Okay. Can I cross cancel any? X plus 4s. What are you left with on top? What are you left with on bottom? Okay? Now, can I make this a lot bigger? Yeah, I can make you have to work on the top and the bottom. I can make these denominators where you have to factor them to find a common denominator. Because remember yesterday, okay, in order to find a common denominator, all the denominators had to be fully factored. Everybody understand? Okay, so that's the kind of stuff you're going to get into. So I'm only going to work one more problem. So instead of just throwing you in there and letting you go after it, I'm going to kind of guide, just to give you a little bit of guidance. We're going to just do it a little bit at a time and make sure you're keeping up. Okay? So here's the problem. I'm going to tell you where I'm getting the problem. I'm getting the problem because they don't have any more on the examples in the book. I just went to page 587, and I'm going to do number 36, which happens to be the very last problem before the challenge. So what does that tell you about it? Yeah, it's going to be a pretty intense problem, okay? Probably about as intense as they will get this year. Okay? All right. So here we go. On the top, 1 over 3x squared minus 3. On the bottom, 5 over x plus 1 minus x plus 4 over x squared minus 3x minus 4. Okay, I'm going to give you about 15 seconds, and I want you to fix the first thing that you should fix. The first thing that your teacher taught you to do in this problem. All right, you got it? What'd you do? Very good. Change this right here to a plus sign and then did what? You pulled that negative, y'all. You can't just stick it on the front. You got to pull it right here, too. I'm even going to go so far as I'm just going to erase that thing and make it a minus. Okay? Now, huh?
If it was x squared on top, would it still be a negative?
Yep, it would be. Doesn't matter what it is. There are no exceptions to the rule. Okay? And what that would do to that, think about that. What it would do to it, it would always make it a negative number. Because it would be a number squared, and then you're taking the opposite of it.
So parentheses another number.
Yeah. Okay? All right. So, let's see. Now, what was that very first rule that we had to have? One fraction on top and one fraction on the bottom. So that's my goal, guys. Okay? I got one fraction on the top. Do I have one fraction on the bottom? Okay. So I'm trying to make one fraction on the bottom. That means I have to add these two fractions. Did you learn how to do that yesterday? So you do it right now. You do it. Don't write the top down. Just do that. Is that what we did yesterday? Remember? Got to factor it. I'm just going to do it up there, guys. There's no sense in rewriting the whole entire problem. That takes up time, okay? Guys, when you're taking a test, is time valuable? Oh, very valuable. Some of you, more valuable than others, because you don't get finished sometimes. And I'm going to tell you what, the SAT test, do you think it's valuable? Oh, people, they'll give you 30 minutes and 25 problems, okay? So you better know what you're doing. All right. So then we looked at these two and we said, well, let's have a common denominator. What's the common denominator? X minus 4 and times x plus 1. Remember what I just said. You got to have every factor, so I got to have an x plus 1. It doesn't matter the order that I write them in, does it? You got to have x minus 4. I ain't got one, so I'll put one down there. I got to have an x plus 1. I already got one of those, so I don't need another one. Okay? Now, what do I do to this denominator to make it look like this? What am I multiplying by? Who's missing? All right, so that's what I'm going to multiply the top by, x minus 4. And now what do I need to do? Yeah, do it, guys. Don't just put it up there. Do it. This is where the kids got messed up. They wrote it up there, and then they went to the next part of the problem. And then they wrote down 5 times x minus 4 times negative x minus 4. I'm like, no, people. That's a plus sign. Don't leave him out. So, let's do it. What do you get? Oh, sorry. 5x minus 20. Very good. Okay? What do you do to this denominator to make it look like this? Nothing. So don't do nothing to the top. Just write it down. Minus x minus 4. Okay? Now, let's go ahead and factor this thing up here. Because eventually what I'm looking to do is flip this thing down here. And then if I can cross cancel, that's what I want to do, right? So let's go ahead and work a little bit on it. What do I see I can do? Take out a 3. When I take out a 3, what am I left with? Oh, what do I know about that? Yeah, that factors into conjugate. That's the difference of two perfect squares. What does it factor into? Now, some of y'all might just want to erase that. Or you might even want to go up here and go, that's 3 times x squared minus 1. Oh, that factors into. Okay, I'm okay with that. I'm okay with that. Over here, I'm going to collect like terms. What's 5x minus x? What's negative 20 and negative 4? Over x plus 1, x minus 4. Now, have I accomplished my goal? Yeah. I got one fraction on the top, one fraction on the bottom. Okay? Huh? I can still factor, and some of the kids wanted to, and I'm okay with you doing it. Okay? I'm going to leave it alone for a minute because a lot of kids wouldn't do it, but I'm okay if you do. I'll show you what you get both ways. So let's multiply. Let's flip it and multiply, people. We're on to 2. So the bottom goes on the top, and the top goes on the bottom. Can I cancel anything? Oh, yeah. Okay. No. Okay. All right. So what can I cancel? X plus 1. Anything else? No. Guys, listen to me. I want to show you something. You need to be really neat and careful. Because watch, if I'm just sloppy and I do this, what's going to happen when I start looking for my factors left on the bottom? Yeah, you're going to think the 3's out, okay? So be very careful when you cross stuff out, all right? You're just going to have to watch for that kind of stuff. So what are you left with on the top? Just an x minus 4. What are you left with on the bottom? 3 and x minus 1 and a 4x minus 24. Now when I see that 4x minus 24, my brain goes, oh, you should take a 4 out, right? If I take a 4 out, what am I left with? Does it help me in any way? Can I reduce anything with it? Then I'm leaving it just like this. Okay? Or, Spencer, some of the kids took it out over here, and here's what they ended up with their answer. 12 times x minus 1 times x minus 6. That's okay, too. I'm okay with that. Okay? What I do not want you to do is I do not want you multiplying this mess out. Okay? It's like I'm asking you not to do work, and then somebody, I know they're going to do it, but y'all listen, when I'm grading papers and 70-something papers, and I got to go through here, and 3 people multiplied that and got x squared minus 7x plus 6, and multiplied by 12, got 12x squared minus 84x plus 72, and I got to do that in my head, that just kind of irks me. Okay? It just makes me snarl. And then I want to look at all your stuff and make sure it's all exactly correct instead of just glancing over your paper and checking it really fast, making sure the answers all look like they're supposed to. Okay? All right. So, anybody have a question? Either one of these answers are acceptable. Okay, anybody got a question? All right. So, I'm through with what I'm going to do. I've given you 2 problems on the board. I'm just going to write them down here for the kids that happen to be watching the YouTube video. All right? And I want you to do those 2 problems. Now, listen to me. This is what you should be doing anyway. I'm giving you 2 problems to practice it, to see if you really know what you're doing. How are you going to know if you know what you're doing? Yeah. See, I wrote the answers down there for you, okay? And then, if you know what you're doing, then get your worksheet out and practice and do your worksheet, because that's for a grade, okay? So, I'm just going to write them on here. Y'all go ahead and get started on them. If you need some help, I'll be happy to help you. You can help each other, but you need to be working.